Everybody, tonight we have a couple of summations with unusual sum ends. Normally you see something in here like 2i or something that's a function of I. Here we're just summing up ones in both cases. Now the a and b are involved in the upper and lower limits of both of the summations. Okay, so it's really, we have to determine those values based on this information. Now what I'd like to do is work kind of with a more general case so we can establish a general formula. Let's say that, I'll just pick some numbers here. We'll pick n equals to 11, and maybe m equals to 8. All right, to get a feel for what's going on here. All right, where n is the upper limit of this more general summation result formula. Now, notice what that would end up being. That would end up being summation 8 to 11. Okay, and again, there's no I here, there's just a 1. Okay, so this is a 1. But what does that mean? Well, for I equal, let me write down I equals 8 here, folks. I equals 8. Okay, so for I equals 8, we get 8, right? For I equals 9, sorry. All right, let me erase here, losing my mind. So for I equals to 8, we get a 1, right? For I equals to 9, we get another 1. It's a little weird, isn't it? But it's just a function of I, but it's just a constant function, which is a constant function of 1. So 1 plus 1 plus 1. And notice that this is equal to 11 minus 8 plus 1. See, it's a little strange. You would think 11 minus 8 is 3. Answer, no. It's 11 minus 8, which is 3, and then plus 1, which is 4. All right, folks? Now, what does that do? That gives us a hint over here on a more general formula. This is always going to be equal to n minus m plus 1. Okay. Now, I've done a few videos on this, so you guys have probably seen this. But this is a general result, and so now let's use that to solve our original problem. So I've rewritten it right here, folks. Now, so for in this particular case, just using this result twice, we would have this is equal to a minus b plus 1. Plus 1, folks. And again, I'm just appealing to this result that we kind of informally proved right here. A is the top limit, B is the bottom limit, so we get a minus b plus 1 is equal to 73. And you see we'll get two equations, two unknowns. It'll be just kind of a standard problem at that point. Okay, now right here, this is equal to 2b minus a plus 1. All right, folks, so I'll just come right underneath here. Notice the 1 will come to the other side over here. This 1 will come to the other side. And do a subtraction, you'll get 72 is equal to a minus b. Okay, and then over here we'll end up with 26 is equal to 2b minus a. All right, so again, a standard, very standard problem with integer solutions. We can tell that's going to happen. All right, now notice that if we add the two equations together, the a's will eliminate here. The a's will eliminate, and so you would get 98 is equal to b. And I'll just say it rather than write it down. If we add this equation to this equation, the minus a is going to cancel with the plus a. We'll add the minus b to the 2b to get the b that you see right here, okay? Then 72 and 26 is equal to the 98. So we know that b is equal to 98, okay? Now also you can see quickly that a must, this would imply that a is equal to would have to be 170, right? 170 minus 98 would be 72. So this would imply that A is equal to 170. Alrighty, folks? So those are the two answers. Okay, A equals 170, and B is equal to 98. Enjoy the rest of your evening.